So, good day student. Magnetism and matter. So, good day students. Now we are going to see a new one more topic of magnetism and matter in our chapter, in the physics division. So, the magnetism. Magnetism, we already discussed a lot of magnetism. Current and magnetism is again we are discussing, right? So, magnetism and matter. If you take any material, it has a magnetism property. So, any material if you take, what is the definition for magnetism then? If you take any material, that's why magnetism and matter. If you take any material, what is the criteria to be the magnetism? What is the criteria, main criteria? It has to be attractive. No, if it is magnetism, it will show attraction. For that it need not be the, it need not be the thing. What is the main criteria?
Unpaired electron.
No, that's different. That's also different. Matter. This matter and magnetism both are connected. Now, what is matter? Matter is nothing but material. If you take any material, you take this table itself, you take this material, it should be magnetism. What is the main thing to be the magnetism? If it is process magnetism, what will have its content? What is its character? Main character? It will show the north pole and south pole. If it, that means the magnetism means that it's showing the north pole and south pole. Top one is the north pole, bottom will be the south pole. That is the main criteria to the for the magnetism to be the thing. That means any why we are differentiating the north pole and south pole. That means I'm having this table. This table is now a magnet, a big magnet. So top one I am creating as a north pole, bottom as a south pole. That means what? No, that everybody knows. North pole repulsion and north pole and south pole attraction. My criteria, my question is that I am assigning this table as the magnet. Now it's a very big magnet now. So top layer constitute the north pole, south pole constitute the bottom layer constitute the south pole. That means I am differentiating the magnet. That's all. Magnet remains same. For any magnet to remain the same, it's the same. Only I am differentiating the pole. That means it has two poles. So that means what now comes the criteria. What makes the differentiation of north pole and south pole? Based on what makes the difference of north pole and south pole? North pole and south pole based on the top one is north pole, top is north, bottom is south. What makes the difference of north and south? That means charge. Charge. But why are you blinking like this? This I already told many times, right? For a magnet, I am having this magnet. I am having this table. This table is assumed as magnet. That's all. So north pole and different. Now top is north pole, bottom is south pole. So this table should be a north pole means it has that character. Charge. The accumulation of charge is this one. North pole is different from the charge of the south pole. That's why north pole and north pole will attract. North pole and south pole? No, north pole and north pole will repel. North pole and south pole will attract. So that means what? That means what?
Different charge.
Different in charge. A different is charge will have a force of attraction. So this comes our example as now I am going for Earth. Now I am going for Earth. Earth versus how many planets is our solar system has? 9 planets. What are the various planets? Mercury, Venus, Earth, Mars, Jupiter, Saturn and Uranus, Neptune. So if I take this series, I am taking 2 planets now, which is Earth and Mars. What is size of Mars? Size of Mars. Half of the size of Earth. Half of the size of Earth. So, how many days it will take, how many hours it will take Earth to complete its rotation? Earth. No, complete its own rotation. Earth will complete its own rotation. 24 hours? 24 hours. That means how much hours it will take for Mars to rotate its own rotation? 12 hours. With respect to Earth, that with respect to this, that is different. With respect to Earth, it takes 12 hours. That means the size decreases means rotation will obviously decreases, because so Earth is now Earth is assumed as a, let us assume Earth as a bar magnet. Why Earth as a bar magnet? So Earth and Mars are so which what is the main center here? Main center, main constituent. Sun is the main constituent. So Sun is the main constituent. Earth, no, you leave it about other planets. Just two planets we will take, Earth and Mars. So Earth and Mars are revolves in elliptical position with respect to Sun. So with this so in this concept, now if you take in the assumption that Earth as a magnet, Mars as a magnet, let us assume Earth has lost its magnetic power. What will happen now? Let us assume Earth is revolving around Sun. Let us assume Earth has lost its all magnetic power. What will happen? Huh? Huh? You understand my concept? Earth is assumed as Earth and Earth. No, first forget only you take Earth and Mars. We will talk about Mars. Second point. First point is Earth. Assume that Earth has lost its all magnetic power. Magnetic power means? No, magnetic power. Magnetic means it has lost its magnetic power. So see, that means I am taking paper, adding the iron particle. Now I am taking silica particle, sand, pure silica particle, add to the paper. I am moving the magnet. The iron particle will move. Okay. Here I am moving silica particle below silica particle and moving the bar magnet. So will silica particle move?
No, sir.
No, because it has lost. It don't have a magnetic power. This has a magnetic power. Let us assume Earth has lost its magnetic power. What will happen now? It goes randomly. It will not do attraction. There is no attraction force. It has lost its power randomly. It will oscillate where the wave pressure is there. Where more wave pressure is there. Okay. For example, I am going to the LIC. Everybody knows LIC. Where is LIC? Here in Anna Sala, LIC is there. It has, I think, 20 floor. I think 20 floor, right? I am taking one ball. I am throwing a ball from the top of the thing. Where the ball will flow? Whether it go from downstairs or it go to space. Downstairs. Why the downstairs? Because center of gravitational force. Due to gravitational force, a ball will flow towards the down. Now this concept will get. So let us assume Earth has lost its magnetic power. So magnetic means what will happen to now? What will happen to the Earth now? Earth will lost its position. The Earth will be losing its orbital position. So when its Earth is lost orbital position, what will happen? It will move randomly where the pressure is higher. That is, let us assume the Earth is today, just now. This is the time Earth has lost its power. So now, what is where will be the position of Earth now, and what is the position of Earth tomorrow, and what is the position of day after tomorrow? Let us assume today, now, this is the time the Earth, today Earth has lost its own power. That's all. So what is the position of today, tomorrow, day after tomorrow? It will move randomly. So it can go to anywhere. So we cannot no definition for that. For example, if today is lost means tomorrow it could be in the position of Mars, which is away from the things. Then day after tomorrow, Jupiter. But it cannot be in the position of Mercury and Venus. Why? Because that possibility is no. See, the Earth has lost its magnetic power, so it can come towards Sun also. No. Why?
There is no pressure. High pressure is there.
Yeah, high pressure is there. Entire Sun is there. No, that's a very big magnet that will try to force pull the any particle. It will not attract the particle. If you have magnetic power, it will be attracted towards Sun. It has lost the power, so the extra force will be the high pressure. Sun is made up of high pressure thing, so any particle goes beyond it will try to pull away, because that's why you know, right? Just now yesterday only I told, asteroid came in 2020 May. Okay, it has passed which is distance from Earth to distance. It's passed I think 1 lakh kilometer. Now it is last week this today May didn't ends, no, May first week it has passed through another near to Earth orbit, which is 5 lakh kilometer. So that one is 1 lakh kilometer, 5 lakh kilometer. So in that case, it so how many years it took? It took 2 years. So 1 year to pass the sun, and another 1 year coming out from the sun. So in this case, it should be attracted to a sun can observe. No, what is the size of sun with respect to asteroid? Earth, asteroid. You see, size of asteroid to the Earth. What is the size? Ratio between what is the size of Earth compared to asteroid? Asteroid will be normally bigger. No, it could be anything. It could be bigger. It is approximately 10 kilometers square. Earth is 6,000, 10,000 kilometer. Total radius, total diameter is 10,000 kilometer. This one is 10. So 10,000 divided by 10. 10,000 divided by 10. 10,000 divided by 10. 10,000 divided by 10,000. 1,000. So that means any asteroid comes means the compared to Earth, it has a size of 10,000 times. So 1,000 times Earth is bigger. Now compared to Earth and Sun, what is the size of Sun with respect to Earth? What is size of radius? I think 10,000 kilometer. What is size of Sun? Size? More than 100 times. 10 lakh, it will be more than 1 crore kilometer. So if you compare the ratio, Earth and Sun ratio, it will be million times. Earth diameter of Sun with respect to diameter of Earth. So it will be ratio. That ratio will be almost
more than 1
million. It will be approximately million. What is million?
10
10 lakh?
more than 10 lakhs.
No, 10 lakhs. 1 million constitutes 10 lakhs. That means size of Earth to the size of Sun is how many times bigger? Size of sun, Earth to the size of Sun. 10 times. Million times. So million times means size of Earth and to the size of Sun, it is million times bigger. So now if you go for any asteroid, an asteroid to the Sun size, how many times it will be bigger? It will be billion times. You understand the concept? Size of Earth to the size of Sun is million times bigger. Asteroid to the Sun, it will be a billions. So billion times bigger than thing can attract this. Can attract the Sun. Can attract the asteroid. No, it didn't attract the asteroid. Why it didn't attract the asteroid? It is passed to the exact pathway. Then it passed to the exact pathway. And then it has passed. That's why in 2020 May it is passed. No, that distance is different. That distance is constant. I think how many kilometer? 1 lakh kilometer. Now it has travelled in the 5 lakh kilometer. So when it travelled in the 1 lakh only, they viewed telescope, and they named also that asteroid. I forgot that name. Okay. So it has passed through the Sun and came back. But why the Sun didn't observe it? Huh? Sun will not observe it. When the Sun will see particle is there, I am having magnet, I am having paper, I am having a particle, iron particle. So when I move it, particle will also move. Because why? If I kept very near to it, particle will stay there. So it need a force of attraction. That force of attraction will there, provided two particle exist the magnetism. So but here I am moving the magnet, taking paper, silica particle. I am moving the magnet. Will the particle will move? No. So there is no force of attraction between particle and magnet in silica particle. But here it is a there is a force of attraction. The magnet
and the
iron particle. So Sun will observe any planet, provided they have the force of attraction. So when Earth lost its power, it will not. Let us assume Earth has lost its magnetism. Earth is a huge magnet. Why? First you have to tell this answer. Earth is a very big magnet. Why? How? Earth is huge magnet, so we divided into north as a north pole, south as a south pole. In between is equator, because it has a huge amount of iron particle in the inside the earth. Inside the core of earth, we have a huge amount of iron particle. Okay, so that makes the earth as a magnet. Let us assume we have lost all the magnet, so it lost its magnetism. So earth will move away from the sun, not towards the sun. So the force of attraction. So when it moves towards sun, what it will do? It will travel towards the mass, and travel to mass. There is a mass belt. What is mass belt? Mass belt. Mass belt is a belt that is situated between Mars and Jupiter, where all asteroids are formed. All asteroids are located. It's not one or two asteroid. One or two asteroid. It has in that belt. There are millions of asteroids there. That asteroid only in the belt. So that also rotating around the. Between Mars
and Jupiter.
That is rotating around the planet on the path between Mars and Jupiter. That is also revolving around the sun. So various planets you having, but the specific planet, Mars and Jupiter is specific because they are having the mass belt. So that is called mass belt. So Earth will Earth will lost its power. So it will travel towards the mass belt and will be located will be staying there forever in the mass belt once it lost the magnetism. So that is what the magnetism plays a role, by which you can see. Now comes the mass, earth and mass. So earth rotation is based on the total number of constituent. If the mass is less, mass second planet, if its size is half of the earth. So what is the rotation? It will be rotation 12. So half of it. So that means the mass is directly proportional to the rotation, by which you can say that it has a core content of iron particle. Core content of iron particle that is present in the core of the earth, compared to in all it will be there in all the planets. So it will be there in all the planets. So here comes the magnetism plays. So magnetism plays dominant role in everywhere. Without magnetism, nothing will no planet will exist. Okay. So where we left? Yeah. Then what is the first one?
Equations.
No, which is the topic?
Magnetism and matter.
No, magnetism. Okay, which one?
Dipole in the uniform magnetic field.
Dipole in the uniform magnetic field. What is a dipole? What is the momentum of dipole? Dipole is charge separation. For example, if you take, I am having one. This is a magnet, which is north pole and south pole. Okay, anything you can take. If this is north pole, this is south pole. If this is south pole, this is north pole. Okay. So let us assume this is a north pole and this is a south pole. So the charge is here. Dipole momentum. Generally, the dipole momentum is separation of charge. Separation of charge means here it is. Let us assume here positive and negative. If there is so the rate of change of the separation, the rate of the charge separation is, that is not charge separation. The amount of charge present here in the north to the amount of charge present in the here will be here. Let us assume amount of charge present in the north is positive. Let us assume positive. So this should be negative. So the change in the thing is
Charge.
total number of here is positive. Total number of here is negative. So the change in the difference is charge difference. Zero, correct. That is a dipole momentum. That is the total charge should be 0. If it is positive is greater, means what will be the things? Greater than 0. That is some charge is there. Positive 0. So that means the change of the charge is 0. That is a dipole momentum. So the dipole momentum, what equation I give? B is equal to 4 pi square divided by m square. What is t? What is m? M is the
M is the magnetic momentum. B is magnetic field. T is time.
time period. Then Gauss law is given by E into delta S equal to Q divided by E0. Okay, what is E? E is electric field, delta S is the area, is equal to charge divided by permeability. E0 is permeability. The net flux of any closed charge is 0 for a given area. In a given area, the net flux is any closed area is 0. Then magnetization and intensity. The magnetization is given, okay, magnetization, that and all you know. Magnetization versus intensity. What field I gave? M is equal to? No, M is equal to?
Lambda h, B equal to mu h.
M is equal to lambda h, B is equal to nu h. What is M? M is? Magnetization. What is nu?
Permeability.
No, not nu. M is equal to what? M is equal to?
Lambda h.
No, it's not lambda. It's not lambda. Susceptibility. Lambda is not lambda. Lambda is different. It's not lambda. Susceptibility. M equal to susceptibility into H. What is H?
Magnetic intensity.
Magnetic intensity. So magnetization is equal to susceptibility into magnetic intensity. Now B is equal to nu into H, where nu is the permeability, B is the magnetic field, H is the magnetic intensity. That's all. And then we go for magnetic properties. Magnetic properties, I already told 3 types magnetic property: paramagnetic, diamagnetic, ferromagnetic. Paramagnetic, the momentum, the magnetic magnetization, the magnetic not no, that's okay. Unpaired electron is the things. No, it's not like that. No.
Listen, unpaired electrons present and arranged in
Random direction. Oh no, magnetic. No. That domain. The unpaired in electron number of. Everybody will have a domain. Okay. In the domain only, you will have the magnetic electrons. All the electrons are paired. So in diamagnetic, no problem, because in all the electrons is paired in diamagnetic. So we don't have any problem with diamagnetic. In paramagnetic, the unpaired electron will be
arranged in
random direction. In ferromagnetic,
same direction. Unpaired electrons are arranged in
same direction. Where it is?
In domain.
In domain. Yeah, correct. So the unpaired electron is unpaired electron is arranged in the random direction in all the domain. In all the domain. Domain. What is the domain then?
Electrons pairing.
No, it's a small area. All small area constitute the domain. So all small area constitute the domain. Then in ferromagnetic it is? In ferromagnetic it is?
Same
All
direction.
the unpaired electron will constitute the in the same direction. So magnetism will be higher in the
Ferromagnetic.
compared to paramagnetic. How?
Because random direction means it will paired. Same direction it will not pair.
It will not paired. So in the same direction means it will not be paired. So it will constitute the more number of highest magnetic strength. So it will lead to the highest magnetic strength. This value I gave, M is equal to C B0 by T. Magnetization is given by C into B0 by T. T is the absolute temperature, B0 is the magnetization, M is equal to C into B0 by T. M is magnetization. C is Curie constant. C is Curie constant. Curie constant. B is magnetic field strength, magnetic field strength. B is magnetic field strength. Then T is temperature. Hysteresis loop. So hysteresis loop. What? Okay, hysteresis loop. What I am doing? I am increasing the magnetic field. I am applying the magnetic field. I am applying the magnetic field. I am seeing the output. Okay. So if I increase the magnetic field, what will happen? The magnetic strength will. I am taking any magnet. Okay. I am taking the material. Okay. What I am doing? I increase the magnetic field. When I increase the magnetic field, what will happen? Magnetization will increase. That means what? I am increasing the field. I am increasing the field in one direction. So what will happen to the magnetic strength? Magnetic field versus magnetic strength. So that is BH. What is B? Magnetic field. What is H? Magnetic intensity or magnetic strength? Both are same. Okay. BH. So I am increasing. Let us assume this is the material. Okay. I am increasing the magnetic field. So what will happen to magnetic strength? I am increase. Why it will increase? Will apply magnetic thing. This is a thing material I am taking. I am increasing the magnetic strength. 1, 2, 3. So various strength I am increasing the magnetic field. Magnetic strength I am increasing. Magnetic field I am increasing. So that means magnetic field increase. So what is the output? Magnetic strength, magnetic intensity. Magnetic intensity increases. Okay. How? What is the difference between ferromagnetism and diamagnetism? Ferromagnetism and diamagnetism. What is the difference? Paired electron. In ferro? Unpaired electron. So if I increase the strength, what will happen? If I increase the, what is between different paramagnetic and ferromagnetic? For diamagnetic you don't have problem. You can skip because its electrons are paired. So you can skip throw away. You can take paramagnetic and ferromagnetic and increasing. You can take the, what is the difference between paramagnetic and ferromagnetic?
Paramagnetic means unpaired electrons in random direction. Ferro means unpaired electrons.
Same. No, unpaired electron. All unpaired electron in the same direction. So now if I increase the field strength, what will happen? All electrons will be moved towards the same direction. All electron will be in the same direction. If all electrons in the same direction, what will happen to the material? Its strength will increase. That's why the strength is increases. So that means if I increase the field, if I increase the field, the strength will increase. Why the strength is increased now? Because of same all unpaired electron are in the same direction. So if I now I am decreasing, now I am changing the direction of the field. Okay, I am doing like this. I am doing instead of moving like this, I am doing like this. What will happen now? The same strength will decrease in opposite direction. The electron which is facing north pole, now the electron will all the electron will face in the south pole. So the magnetization remains same, but direction only changed. So okay, you understood? So because in north pole it is everything. Let us assume I am increasing the field. All electron are faced in the same direction. Same direction you keep as north pole. Also now all the electrons are now increase the magnetization. now increase the magnetization, the all electrons are faced towards the north pole, because let us assume all the electrons are faced to north pole. So magnetic intensity will increases. So now I am reversing the magnetic field. Reverse the magnetic field in the opposite direction. So all the electron will face towards now south pole. So it will come back, but the magnetization will remain as the same because the strength is same, direction is difference. Then again I am increasing it. Now again I am increasing the magnetic field strength in this x-axis. What will do? All the electron will face towards now
Same direction, north pole.
in the same direction, north pole. That's all. So that's why this loop is called hysteresis loop. See, now it's completed the loop, right?
Yes, sir.
Yeah, do you have the diagram?
Yes.
See, now it is completed the loop. It is going to the north. Top point is the top point. What is the top point?
North.
North pole. North pole. Yeah, I want to say simply. I want to tell you a simple fashion, which is one direction, which is in the north pole. So downward it is
South pole.
south pole, which is downward direction, up direction and downward direction. So the magnetization north pole and south pole point, magnetization is strength is same,
But it is
the direction is different. That's all. Yeah, over no.
Sir, BH cover B என்ன H என்ன sir?
B is magnetic field.
Magnetic field.
H on the strength or intensity. Magnetic field is the one that you. What is the magnetic field?
That is magnetic.
No, what is the magnetic field? Magnetic field is a strength that we are applying. Magnetic strength or magnetic intensity is the one that's the output. Yeah, input output. Magnetic field is the input, means magnetic field H is the output. Input output. That's all. That's all over.